Welcome, welcome, welcome to our first video of this math school year. We're working through chapter 1. We're going to touch on lesson 1 and then we're going to jump all the way to lesson 4. The things we're going to cover today are looking at rates and ratios, proportional and non-proportional relationships. We've been talking about these for quite a while, but now it's finally time to get some notes down so we know exactly what we need to do when we see some of these problems and we start getting some homework questions. So we're ready to dive into it. What I do need is this Chapter 1, Lesson 1, and Lesson 4 at the very top of your notes section, and then let's dive into this notes. First thing I do want to point out is this section up here. If you'll notice where my cursor is right now, you'll see different symbols. This is definitely a stop symbol, then a listen, and then a right symbol. Whenever you see this combination, that means I'm expecting that everything that's on my slide gets put into your notes. I might break some of these off, or I might just have you just listen or just to jot something down quick, and so then I'll just throw those symbols up at the top of each progression along the video so you know what needs to go into your notes if I don't say so. So these three things are just going to go right into our notes, and these are just very quick little definitions as to what we need to know before we start off. And some of us, we've talked about this already, so it's going to go really fast, but our first one is just what a ratio is. Ratio is just a comparison of two units. This can be miles per hour, this can be miles per gallon, days per week, anything that compares two different units of category of things. And that's what a ratio is. So pause for a second, get that into your notes, and then when you click play, we'll get unit rate. For unit rates, we have those where we kind of connect a ratio, so now we're using our buzzword already, so a ratio, whose second unit has a value of 1. So where a ratio could be 360 miles every 6 hours, because we have our two different units in miles and hours. A unit rate will be a ratio, so again, two different units, miles, but then the second number is only going to have a value of 1, so that's just 1 hour. And so a lot of times I'm going to ask you to turn something to a unit rate, and that's by taking a ratio and turning it into unit rate by figuring out how many miles per 1 hour, how many days per 1 week, how many words per 1 minute, stuff like that. So in a unit rate, when you hear that word unit, that means the second number always has this value of 1. Finally, we have this really long, confusing thing called the multiplicative identity property. That's really straightforward. This is something you've known for a long time, but now we're just putting some complicated words to it. So go ahead and jot down multiplicative identity property, and then all we're going to use is some symbols to represent what that means. All the multiplicative identity property says that I can take any number times 1, and that equals that number. And on the flip side of that, that means I can take some number divided by itself, and it will always equal 1. So we're going to use these two set of symbols to represent what the multiplicative identity property is, because we can put any number in this box, and as long as it's the same number here, we know we're using that multiplicative identity. Same thing with division. If I start with a number divided by itself, that equals 1. So both of those are going to be useful for us using ratios, so make sure you have those examples on. Go ahead and click pause if you need to finish up, and then click play when you're ready to start again. Here we just have a quick example. I just need you to listening on this one. And so in this example, we're just turning a ratio here, which we have two different units. We have beats and we have minutes. And we're going to turn it into unit rate here. And I'm going to show you just quickly how they did so. So we're going to turn a ratio into a unit rate. So now I have this denominator, or this second number has a value of 1, so that's how I know it's a unit rate. And they're going to use this multiplicative identity property we mentioned before. Because I know that 2 divided by 2, so 2 divided by itself, equals 1, I know that I have this as this kind of little multiplier that is kind of allowing me to get from a ratio to unit rate. So now I can take 160 divided by 2, and I'm going to get 80. And so that's how I know that they're equal to each other, because they have that same number. And I'm using this multiplicative identity property by saying I can divide a number by itself to equal 1, which allows me then to prove that we are getting 80 beats every 1 minute. So again, that was just a quick example to show. We're going to practice a couple more. So here we go. Here's a shortcut to unit rates. Rather than having to do all that kind of stuff with the multiplicative identity and saying, okay, I need to divide this by 2 and then divide this by 2, a shortcut that you can do is recognizing that this fraction, or ratio in this case, or what looks like a fraction, is actually a division symbol. So when you're trying to get to unit rates, and we know that we have that multiplicative identity where I know any number divided by itself equals 1, I know my job is to get this something over 1. So all I need to do is I know I'm going to be dividing 2 divided by 2 to get over here. And now I need to divide that by 2. But if I look at this is a division problem. I can take 160, this fraction bar right here means division. So now I can take 160 divided by 2, and I'm going to get my unit rate. So if I do just a quick division problem, and I say 160 divided by 2, 2 goes into 16 8 times, 8 times 2 is 16, subtract those away, bring down my 0, 2 goes into 0, 0 times. So now it's 2 times 0 is 0, subtract, I have absolutely nothing left. I know that I'm getting 80 beats per 1 minute just by using division. So you don't have to go through that whole kind of looking at that multiplicative identity property. If we're doing these, we just use this division bar and to say 160 divided by 2 and you have your unit rate. Make sure you do jot that down, that we can just use a division process to get us to unit rates. So shortcut to unit rates is just divide. Just divide. So even if that's what you want to have in your notes, just divide. That's a nice shortcut. Here we see a ratio table, and that's just a sequence of ratios. So we have earnings in dollars and time in hours. So everything in this top section represents dollars, everything in this bottom section represents hours. So now we have 1 ratio, 2 ratios, 3 ratios, and 4 ratios all in one table. So again, a ratio table. And so I want to have you jot this down using our symbols up here, just so we can know how to solve those ratio tables. Some of you may know already, and some of you have practiced, and we've been paying attention about how we do so in class, but we want to have these in our notes so we know for sure. And we're going to use a method called outer rainbows to help us solve. And you've seen me do this on the board. You might have practiced it. You might not have set anything up, but you've seen me try it before. And so what I'm looking for is I'm looking for a way that I can get from any of these known numbers here, any of these known numbers, to fill in this blank number. So I can use my previous knowledge to fill in this blank. All right, so what I'm going to use is the outer rainbows. And I know just from the multiplicative identity that I can take 1 times 2, so I take a number times 1, and it equals itself. So I know if I can go from this first ratio table, or this first ratio, to the second one by multiplying by 2, whatever I do to the bottom, I must do the exact same thing to the top. So now I know I can just multiply 18 by 2. And a quick multiplication shows me that 2 times 8 is 16, and 2 times 1 plus 1 is 3, so that must be 36. Oh, that is not a good color. Let's go black. 36 in that box. So that means if I earn $18 every 1 hour, I should earn $36 every 2 hours, 54 every 3, 72 every 4. And we call this outer rainbows because we made a connection between 2 ratios outside of the problem, and they kind of form a little rainbow shape. So we call those, they're outside of the ratio table, so that's why the outer, and they look like a little rainbow, so that's why we call them outer rainbows. On the flip side, also solve this using inner rainbows. Now you don't need to write this whole thing again because you have this table done already in your notes. So you can just add some extra notes onto this because we're just going to draw a couple extra pictures now using inner rainbows. And what inner rainbows tell us we can solve is that any set of ratios that we have that we can know are consistent would say that I can see that I can now make a rainbow connection between time and earnings. So now I'm inside of the problem, calling the inner rainbows. I'm inside the problem. I didn't go outside the table. And I'm still using that kind of rainbow method where I'm making now a sideways rainbow. And so now I can say that if in getting from 1 to 18, I'm multiplying by 18. That's the connection of this inner rainbow. So now what I can say is that in order to figure out for 2, I can use that same inner rainbow, knowing that it has to be times 18 to get from time to earnings. And now I can just take 18 times 2, which we proved last time was 36. So now I saw 2 different ways. I saw the outer rainbows that connect things outside of the ratio table, and then I saw inner rainbows which connect things inside the ratio table. And this times 18 holds true for every of those. 3 times 18 is 54. 4 times 18 is 72. So now what we're seeing is that there's many different ways to solve and fill in these ratio tables. Again, don't need to redraw this whole thing, but just fill it in on your existing ratio table. Go ahead and hit play when you're ready to keep moving forward. We have 3 more terms we need to toss into our notes, and these are just going to help us move forward. So we're just going to jot these down real quick. Notice that the definitions aren't very long. If you need to take more time, you can always hit pause and pick up again. But we need to identify a couple things because you're going to hear me say them in the future a lot. And these are things that are called scale factors. And so what a scale factor is, that's the multiplier or divisor attached to the rainbow, whether that be the outer rainbow or the inner rainbow. So just kind of calling back to what we had just done, if I had 18 over 1 and 36 over 2, seeing that this was a times 2 relationship, this 2, that's my scale factor, knowing that I have them done for both the top and the bottom. And then this would also be a scale factor if I'm going from denominator to numerator. That was the times 18. That could also be considered a scale factor. So when we talk about scale factors, I'm just talking about the number connected to the rainbow. You can see the 18 connected to the inner rainbow and the 2 connected to the outer. So if I'm asking for those, what's the scale factor on the inner rainbow or the scale factor on the outer rainbow? It's just what's the multiplier or the divisor in between both of those ratios. Secondly, what we have is a proportional relationship. And a proportional relationship is a set of ratios with the exact same scale factor on inner rainbows only. And what I mean by that is that we know that we're going to use this term proportional in the very near future, so I want to give you a heads up as to what it means. If you hear me say proportional, that means we have a set of ratios, like we're going to use the exact same one of 18 over 1 and 36 over 2, and then even 54 over 3. We have that set of ratios that have that commonality of taking denominator times 18 to get to numerator. Times 18, 3 times 18 is 54. So if we can say that we have this kind of constant multiplier and constant scale factor in all of our inner rainbows, we have a proportional relationship. Then on the flip side, again, this is just to kind of give us a heads up for the future. On the flip side, a non-proportional relationship is just a set of ratios with different scale factors. So if you're seeing some different scale factors in any of those inner rainbows, we'll put that inner rainbow part on there. Again, this is just for inner rainbows. If you see that we have any different scale factors in a set of ratios, then we know they're not proportional. We're going to talk about what that means in the future. But I want you to know what proportional and non-proportional means and how they relate to scale factors and inner rainbows. Go ahead and click play when you're ready to move. So finally, we're getting towards the end of our lesson, and the last thing I need you to do is just take a picture of your final notes. That's in case we lose our notebooks, we lose our notes, we have evidence of our notes, and so we can use those and you go back to them. We might even put them in a digital notebook in the future, but we're going to get in the habit of taking a picture of your notes every single time we do a video. And now I'm taking a page out of Miss Doc's book, and so you venture potters out there, this is going to get something familiar. I like to throw a little something in for a joke of the day, and then this is just something that you can put into your notes that shows me that you watched the entire video. This isn't something that you share with other people, because this is the way that I check, did you do what you needed to do, or did you just kind of copy some stuff down? So the answer to this joke, make sure it goes into your notes, and the joke of the day is, what would bears be without bees? Why, they'd be ears. Get it? Bears. Bears without a B would be just ears. Oh man, that's a good one. So, joke of the day, just write down ears into your notes, and that's all I have. Adios, folks. Thanks for listening.